This is solving equations involving single trigonometric functions, meaning there will not be any quadratics here. The next video I do will involve arguments that are 2 theta and 3 theta, where that's the period change. These are quite simple, and the first one we're going to do is 2 sine of theta plus 3 equals 2. Now you solve this like you do a normal equation. So basically, if this was 2, I'm going to make it y since sine is y, plus 3 equals 2, you would subtract 3 from both sides and get 2y equals negative 1. Divide both sides by 2 and get y equals negative 1/2. So basically that's what you're doing here. Since we are solving, remember, you can cross over, whereas when we were doing identities, you could not. So here we go. We're going to subtract the 3 from both sides, and we get 2 sine of theta equals negative 1. Divide both sides by 2, and we get sine of theta equals negative 1/2. Now, if you don't know that already, we know that theta, if you look on your unit circle, is going to be 7 pi over 6, or theta is 11 pi over 6. Now, if they ask, if they ask for all solutions, then you have to put plus 2k pi. That just means that you keep going around the circle several times. So we're down in here and here. That means you just keep going around and around and around. That gives you all solutions. If they're asking for theta in between 0 and 2 pi, then our solution set would be 7 pi over 6 and 11 pi over 6. Please start writing your answers as sets. Okay? Alright, the next one we're going to do is 1 minus cosine of theta equals 1/2. Again, you're solving this just like you would a normal equation. So if I had 1 minus x equals 1/2, what I would do is I would move the x over here on this side. So I would get 1 minus 1/2 equals x. I just added x to both sides and subtracted the 1/2. So that's what I'm going to do here. I'm going to add cosine to both sides, and I'm going to subtract 1/2 from both sides. So here this 2 cancels. 1 minus 1/2 is 1/2. Here these 2 cancel, and I get cosine theta. So you look on your unit chart, and it is theta would be pi over 3, or theta equals 5 pi over 3. If they're asking for all solutions, you add your 2k pi, because the period of cosine is 2 pi, and the k just means how many rotations you go around, and do it over here as well. If they're just asking the first rotation between 0 and 2 pi, our solution set would be pi over 3 and 5 pi over 3. And close it up, and we're done. Okay, the next one. We're going to do 4 cosine squared of theta equals 1. Divide both sides by 4. I get cosine squared of theta equals 1 over 4. Now here I'm going to square root both sides, just plus and minus. In this case, I get cosine of theta equals plus or minus 1/2. So what we're going to get on this one is theta equals pi over 3 plus 2k pi. Oopsie. Plus 2k pi. Theta equals 2 pi over 3 plus 2k pi. Theta equals 4 pi over 3 plus 2k pi. And theta equals 5 pi over 3 plus 2k pi. And if they're asking just between 0 and 2 pi, then our solution set would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now, this is where cosine is 1/2, 1/2. This is where cosine of theta is -1/2, these two values. So you just put them all together. Let's do one more. Let's do one with tangent. We have tan squared of theta equals 1/3. So square root both sides. Don't forget your plus and minus. So tan of theta equals plus or minus square root of 1 over square root of 3, which equals root 3 over 3. Plus or minus, don't forget that. And if let's just restrict the domain between 0 and 2 pi, and our solution set would be pi over 6, 5 pi over 6, 7 pi over 6, and, let me erase this, 11 pi over 6. Okay? The next video I'm going to make has to do with solving general equations for ones like cosine of 2 theta and sine of 2 theta, or even sine of 3 theta and cosine of 3 theta. That's going to be the next video. They take a little longer.